Good afternoon, one and all. So, in the last class, we have seen characteristics and applications of artificial neuron network. So, in today's class, we'll see the types of neuron activation functions. So, what are the types of activation functions for the neural network that we'll see? As a brief, so already we have seen this operation of a neural network. In this operation of a neural network, we have input neurons, and the corresponding connection weights of the input neurons are W1, W2, W0J, W1J, and so on WNJ. The corresponding inputs are X0, X1, and so on Xn. And all these are connected to the output neuron, where all these products of these inputs and corresponding weights will be multiplied, and it will be sum in the output neuron. So that is called weighted sum, and this will be processed through this function. The corresponding function is called the activation function. So the sum or weighted sum needs to be processed through this function. The corresponding function have to be decided based on the application. So the output of the function will give the overall output of the ANN. Then with this bias, if it bias is there, it will be added. If it requires, we can keep the bias. If it is not required, we can keep the bias as 0. So these are the main blocks of the ANN, functioning of the ANN, functioning blocks. So coming to the building blocks of the artificial neural network. So mainly these three are the building blocks of the ANN. One is activation function, another one is network architecture. Network architecture means how the connections between the neurons. It may be feed forward, or it may be feedback, propagation back propagation, a recurrent network. So likewise we have few network types, how many hidden layers, with hidden layers, without hidden layers. So that network architecture we'll see in the coming classes. So there is one building block. We have to select the network architecture, proper network architecture. Whether do we need hidden layers, more hidden layers, less hidden layers, how many hidden layers, whether we need back propagation, or whether we don't need back propagation, that is feedback, whether we need any storage or without storage, recursive, non-recursive. So all this comes under the network architecture. So the network architecture will be decided based on the connections between the neurons. So next thing is setting up the weights. The connection weights need to be adjusted to get the proper output. That means it is called the training, learning algorithms, learning methods. So that is called the training. So we have to provide the proper training to adjust the connection weights. Then only we will get the required output. So these three are the main building blocks of the ANN. In this we will first see the activation function. So already as per the black diagram, let us assume X1 to Xn are the input neurons, and the corresponding weights of the neurons are W1 to Wn. So what is the output of that summing weight? Summing weight, what do you get? Summing weight is nothing but here I, that I is equal to weights are multiplying with the corresponding input neurons, that is W1 X1 plus W2 X2 plus and so on Wn Xn. So that is nothing but the summing weight. All the input neurons are multiplying with its connection weights, and all together if we sum means we will get the summing weight, that is equal to the summation I is equal to 1 to n wi xi, where I is equal to 1 to n. Okay, that means we have n input neurons and n connection bits. So here to get the output y, we are calling it as y. To generate the output y, the sum should be passed through a non-linear filter. So the corresponding filter is called the activation function. Like I discussed in the block diagram, the weighted sum need to be processed through the activation function. So the one function, that function is called the activation function. As this ANN has non-linear capability, we are providing that non-linear function only. So that function is called the activation function or transfer function or squash function. So which gives the required output, overall output. The corresponding overall output of the ANN is nothing but, we can mention y is equal to the corresponding non-linear function, if you are calling it as pi of I is nothing but weighted sum. So your overall output is equal to pi of weighted sum I. So now this I will decide what is the output, and function will decide what is the output. So how means we'll see. So let us take one by one. So one of the activation function here is thresholding function. So what is thresholding function means? Generally this thresholding function is very commonly used function in the ANN. Okay. So the sum is compared with the threshold value theta in this thresholding function. The thresholding function, if you consider threshold value as theta, your weighted sum I, which is nothing but summation I is equal to 1 to n, small I is equal to 1 to n wi xi, right? So this is what weighted sum, capital I is equal to this one. So now in the thresholding function, your weighted sum I is comparing with the threshold value theta. If your weighted sum is greater than theta, then your output value is equal to 1. Weighted value I, capital I, is greater than theta means wi xi is greater than theta means summation wi xi is greater than theta means then output is equal to 1. Else output is equal to 0. Else is nothing but, which is if I, capital I, is less than or equal to theta. Actually here less than or equal to theta, then y is equal to 0. So where what is y means, by considering this threshold value, how the y will becomes means y is equal to pi of activation function, that is pi of summation I is equal to 1 to n wi xi, as we are considering some threshold value, minus theta. So now you are comparing this with this threshold value. This summing weighted sum is denoted as capital I. Capital. Further, if you want to write this equation, y is equal to pi of capital I minus theta. If capital I is greater than theta, your output is equal to 1. If capital I else, y is equal to 0. Like that, we are providing this threshold function. So if you are giving the threshold function like that, the representation of the threshold function is as follows. Here, this diagram indicates the threshold functions, what we have given in numbers or with values here. So on y-axis we will take the output y is equal to pi of I, weighted sum, and input to the activation function is nothing but weighted sum, right? So the weighted sum as on x-axis, which is nothing but input, that is capital I, which is nothing but summation small I is equal to 1 to n wi into xi. This is nothing but weighted sum on the x-axis. So if you see here, this is I, right? X-axis is I, capital I. If I is less than theta, before theta is nothing but threshold value, before theta, your value of the output should be 0. That's what here indicated. If it is greater than theta, your value should be equal to 1. That's what we have indicated here. In a similar way, we have drawn the diagram also. So this is a thresholding function. It's simple to understand. If your weighted sum is greater than the threshold value, you will get the output. Otherwise, you will get the 0 output. Simply neuron will be activated or neuron will be off. Otherwise, 1 or 0 means. Or if you want to represent in another way, your output is 1 or output is 0. Because each neuron need to be connected with the each one of the activation function connection weights will be there. So there is nothing but neuron. That's why this is called the neuron activation function. I hope understood. The next one is step function. Here step function also it is also known as the heavy side function. So where here also will represent the activation function with some pi of capital I, which is nothing but weighted sum. Pi of weighted sum is equal to 1 if capital I is greater than 0. Pi of I is equal to 0 if capital I is less than or equal to 0. I hope you know the step function. So in this step function, if I is input, whatever the function pi of I, this I is greater than 0 or I is less than or equal to 0. Based on that, you are getting the output value here. The function output value, activation function output value you are getting here. So in the thresholding function also, theta, the threshold value you have considered. If you consider threshold value, the theta should be there. Otherwise, theta is equal to 0, right? If theta is equal to 0 means, if theta is equal to 0 in the threshold function, then it becomes step function only. Simply if you see here, pi of I is equal to 1 when I is greater than 0, else it is pi of I is equal to 0, like that we mentioned, right? In the earlier case, in the threshold function also, I is greater than theta, like that we mentioned. If you keep this theta is equal to 0, then it will become the step function. Even if you keep in the representation in the diagram also, if you keep theta is equal to 0 means this entire waveform will come onto this y-axis, right? Theta is equal to 0 means this theta is equal to 0 means it has to come onto this y-axis. So that's what I have represented here. Here output y is equal to pi of I on the y-axis and input I, capital I, on the x-axis. So when this capital I, which is on the x-axis, is greater than 0 means positive axis. When it is greater than 0, your output is equal to 1. If it is less than or equal to 0 means your output is 0. So that's what the representation of the step function, one of the activation function, neuron activation function. Here the output signal is either 0 or 1, which results the neuron either on or off. The neuron is off or on can be decided by this activation function by using this step function, because output you are getting either 1 or 0 means 1 means on, 0 means off. Neuron activation function. So if you see the another activation function, that is signum function. So the signum function is also known as quantizer function. So here also the activation function pi of I is equal to +1 if I is greater than theta. Here also the threshold value is there. If you consider the threshold value, here pi of I is equal to +1 if I is greater than theta, else -1. That is nothing but if I is less than or equal to theta, here activation function output is nothing but -1. That means it will vary between the -1 to +1. Earlier the threshold functions or step function, your output is varying between the 0 to 1 only. But here you can get the output which can vary between the -1 to +1. It is the signum function. The corresponding representation of the signum function is again in a similar way. On the y-axis output pi of I, on the x-axis weighted sum I is equal to capital I. And if you consider some threshold value, from that threshold value, if your I is input which is on the x-axis is greater than this theta threshold value, then you will get the output as +1. Otherwise, for the less than I is less than or equal to theta value, then you will get the output as -1. Okay. So if we see the another activation function, so that is sigmoidal function. In the sigmoidal function, it is a continuous function and which can vary the values between the 0 to 1 or -1 to +1. So the corresponding function is denoted as sigmoidal function. Pi of I is equal to 1 is divided by 1 plus e power minus alpha into I. This is the representation of the sigmoidal function. All these are the standard functions. So where this alpha is denoted, alpha is nothing but the slope parameter. Based on by varying this alpha value, here the output or the slope of that curve will change. Capital I is nothing but the input. First, if you adjust the slope value, then by changing the input value with that corresponding slope, you will get the output output waveform. So here the sigmoidal function adjusts the abruptness of the function as it changes between the two asymptotic values, that may be 0 to 1 or -1 to +1. So how these values are changing between those values mean how this output is changing means, so you can change the input value I or you can change the alpha value, slope value. So here you have two parameters to get the different way of output function. So it is differentiable also. The sigmoidal function is differentiable. So this is one of the important features of the neural network. And if we see the representation of the sigmoidal function, output is represented on the y-axis, input is represented with the on the x-axis. If you see here, this is your sigmoidal function 1 by 1 plus e power minus alpha into I. If you consider alpha is equal to 0.5, you are getting the waveform like this. Your output will vary when I is changing from when I is continuously changing, we will get the waveform like this. And for alpha is equal to 1, the middle curve like this, you will get the sigmoidal function, output function. As alpha is increasing, it will move upper. That means alpha is slope means when you keep this alpha is equal to 0, what will happen? Alpha is equal to 0 means e power 0. E power 0 means this is equal to this entire e power minus alpha into I equal to 1. Then 1 by 1 plus 1 will become 1 by 2, which is nothing but 0.5. So irrespective of your input I, your pi of I will give the 0.5 value. That means with slope is equal to 0, your pi of I will become a straight line and with a value of 0.5. As you are increasing the slope value, it will move upward like this. Further, if you increase, you may get on the y-axis. Complete y-axis if you want to get it means, on the y-axis if you want to get it means, simply you have to get the, you have to keep the alpha is equal to infinity. If you keep alpha is equal to infinity means e power minus infinity, which is nothing but 1 by e power infinity, which is equal to 0, then 1 by 1 plus 0, which is nothing but 1. So your pi of I is equal to 1 with infinity slope. It will come like this on y-axis with pi of I is equal to 1. So this is the sigmoidal function. Likewise, based on our applications, we need to choose the proper activation function to get the required outputs. Even you have other functions like tangential function, which is nothing but tan h, and the radius functions. Likewise, different functions will be there, but these are the basic functions, basic nonlinear activation functions of the artificial neural network. So by using any one of the functions, we will get the proper output. So how do we select that activation function? This activation function selection depends on the application of the application. The corresponding one particular application require one of the activation function. If another application is there means you need to change that activation function corresponding to that application. So it depends on the application for which this ANN is used. Based on that, we have to select this activation function, and also based on the neuron level, how many layers, whether it is single layer, multi-layer. If it is multi-layer means how many hidden layers are there. So based on that also, these activation functions need to be selected. So generally the applications like for prediction type, you may have one kind of activation functions we have to use. For process forecasting, for fault diagnosis, for feature categorization, classification problems. These are the different type. In the different applications, we may do these type of functions or this type of activities we require. Few applications require predictions, few applications require process forecasting, few applications require fault diagnosis, fault tolerance, few applications require that feature categorization or classification problems. So it depends on the application, you have to choose that activation functions, whether it is sigmoid or threshold If some may not do the classification problems for activation functions, in that case we have to go for other activation functions. What based on the drawbacks of the one of the activation function, we have to choose the proper activation functions which fulfills our need for that particular applications. Okay. Thank you. So this is all about the artificial neural network activation functions. Thank you all.